Hi guys! Alright, Logan, we gotta get our face kind of out of the way on this lesson. We got a lot of work to do. So this, Algebra 2 students for 2020, this is technically your last topic for Algebra 2. Yay! So we're gonna have to split this up into 2 days. I think that'd be best. So this is your first video, day 1, and the notes, it's all one big set of notes, and then we're just gonna kind of split it. So today, we're gonna talk about solving rational equations. And once I get my pen to work, we're going to talk about some vocabulary before we talk about the actual solving. So ideas of common denominators is something we're going to take away from the last lesson. Back up one problem. The first thing we're going to talk about, though, is what's called an excluded value. And we've actually talked about this before in Algebra 2. So an excluded value is something that you know your solution can't come out to. So if I think about... That's too loud. Go away with your noisy chips. Our excluded value would mean that our denominators cannot be 0 because we know we can't divide by 0. So that's what I'm going to write down as my notes. I just got to make sure that my denominators, I should say, cannot be 0. So let's take a look at all of our denominators we're working with here. We've got a 2m, which is algebra. We've got a 2, which is never going to be a 0. And then we have an m, which is algebra. So 2m cannot be 0, and m cannot be 0. Well, these are actually saying the same thing, because if you were to solve this, like here you divide by 2, you'd get m cannot be 0. So my excluded value is just that. M cannot be 0. Here's what the excluded value means for us today. If we go through all the work of solving this question later on in the notes, and we actually get a solution of m equals 0, we're going to have to come back and say, cross it off, call it extraneous, because it was one of our excluded values. The other idea that I want to talk to you about is your least common multiple, which is kind of synonymous with least common denominator, except today we're not going to keep the common denominator, we're going to knock it out with a common multiple. So your LCM would be when you look at your denominators and you think about the least common multiple of those. So I go through the list and I notice we have a 2, and yes, it shows up twice, but whatever. They just have that in common. And then I see an m, and again it shows up twice, but they just have that in common. So the LCM for that particular problem is 2m. We're going to come back to using the LCM on 2 questions from now. Okay, so for now, just excluded values and LCM. Ooh. Okay, so this next example, my excluded value would be, if I look at my denominators, and I happen to have the same denominator here and here, we know that this cannot equal 0. So 2x minus 3 cannot be 0. If I go ahead and I solve this, I would add the 3, and then divide by 2. So it turns out x cannot equal 3 halves or 1.5. So for later today, what that means is if we were to go through all that work and figure out like, oh, I got an answer of 3 halves, I'd have to cross it off and call it extraneous. The other idea for this lesson was finding the least common multiple, and that has to do with the denominators. So you got a 1, which we learned from our previous week's work was boring. And then here you have a 2x minus 3, and then here you also have a 2x minus 3. So it turns out on this question, the least common multiple is just the term of 2x minus 3. That's what we're going to have to use to knock out our denominators. Speaking of which, finally we're going to get to the point where we get to solve the equation. So one thing to point out that's different from the previous weeks, these are algebraic equations, which means we're going to be solving them. So all the rules of equations apply. You can do anything you want to the equation as long as you do it to every single term on both sides of the equation. It says, oh, this is a misspelling. Don't forget about extraneous. I think it was supposed to say solutions, which are excluded values. So what we're going to start off with is just that, excluded value. So when I look at my denominators, I have a 5x squared, I have an x squared, and I have a 5x squared. So the algebra pieces, x squared is part of 5x squared. So what I'm going to do is I'm going to set up a little statement that says that 5x squared, my denominator, cannot be equal to 0. And if you were to solve this, you would divide by 5, and you'd still have x squared equals 0. And then this is weird, when you square root of 0, you just get 0 again. So it turns out the only solution that I can't have is x equals 0. So that's not the solution, though. That's the one thing I can't have. So now when I come through and actually solve this problem, if I happen to get 0, I'm going to have to cross it off and call it extraneous. My daughter's doing some division. I got to check her. All right, we're back. So what we're going to do now is we're going to find the least common multiple, which is kind of like the common denominator for this question. And it would have to involve and be able to knock out essentially all of the denominators. So I notice that there's a common 5, and then there's also a common x squared. So that's what we're going to use for our LCM. So what you're going to do here is you're going to put big parentheses around the whole problem. And this is different from the last week, so be careful. We're going to multiply every single term here by a 5x squared over 1. So this time we're not trying to build denominators, we're trying to knock out denominators. So what I'm about to do is show all of the work, and I want everyone doing this with me this way. I'm going to start by writing out the original problem, and I'm going to space it out. So we have x minus, whoops, wrong color. We have the original problem, x minus 6 over 5x squared plus, and then leave some space here. We have x minus 1 over x squared equals, leave some space here. We have x plus 1 over 5x squared. And then in front of each of those terms of the equation, we're going to multiply by the 5x squared over 1. And this is going to look really messy, but we'll make it better in a minute. Hey, Loke. Okay. Now for the simplification bubbles. Here we go. This guy right here is one big multiplication question. We've got some cancellation to worry about there. Something here also cancels. We'll come back to that. And something here also cancels. So this is a neat chapter where like everything kind of builds together. So thank goodness we went slow, right?
I see everything on each of the bubbles.
Yeah, so now we're looking for things that cancel. So if they're on top and bottom, they're going to cancel. So the 5 and the x squared will cancel. And all we're left with is x minus 6. Now notice the denominator has a 1, but we know 1s don't do anything, so we're just not going to write it down. There's a plus sign hidden right here. I'm going to write that down. All right, so over here, Logan, do you see anything that cancels? Anything that's on top and bottom?
5 times 2.
So the x, it's called an x squared. The 5 isn't there, though. We got to be careful. The 5 is still up top. Nothing canceled with it. So what we have here is you still have this 5, and he's going to have to multiply by the x minus 1. Remember, there's like a little multiplication dot here, which Algebra 2 students will tell you means you have to distribute. All right, what about this last bubble, Logan? Do you
1?
No, that's tricky because that 1 is part of the x.
Times 2?
No, that's called an x squared. There you go. X squareds cancel, and the 5 will cancel. So we have x plus 1 again over 1. We don't write that. So your job here on this step was to knock out all the denominators. You should have no more denominators once you do this step. And we did. All right, let's go solve and distribute. So we're going to distribute that 5. We have an x minus 6 plus 5x minus 5 equals x plus 1. Okay, on the left side here, we're going to collect our like terms like an equation. And this is a linear equation, so it might take us a couple steps, but it shouldn't be too bad. This is a 6x. And then right here, if we combine the minus 6 and the minus 5, we get minus 11. I haven't moved anything from this side yet. Okay, linear equations, move x's to one side and non-x's to the opposite side. So I'm going to subtract this x over here. I'm going to add the 11 over here. All right, we are almost home free. Hang tight, guys. We have 5x equals 12. So when I divide both sides by 5, I get x equals 12 over 5. That is a decimal. If you wrote down the decimal equivalent, that's okay. But one thing we got to be careful about is remember back here, we said there's one answer I can't get. I can't get x equals 0. We didn't get x equals 0. So that means that our answer is good. Obviously, when you're doing your homework, you're going to check the key, but that's something to watch out for. So that was a hoot, right? Let's try another one. And actually, this last example is the end of our video for day 1. You're going to practice some of these that have what we call monomial denominators, and then we'll work with binomial and trinomial denominators on the next part of the lesson. So first thing I'm going to come up with, because I always forget it, are my excluded values. So when I look at my denominators, the algebra parts, I got a 5x squared, a 5x squared, and an x squared. Well, x squared is a part of 5x squared because it's 5 times x squared. So all I need to think about is, 5x squared can't be 0. And if I divide by 5 and square root again, like the last question, I get x can't be 0. So I just have to remember that at the end of the problem, if I happen to get 0, that means I got to cross it off and call it extraneous. So now let's talk about our LCM. And I have a 5x squared. This one is the same denominator, so they already have the same thing. And then we just talked about this. The x squared is a part of the 5x squared, right? It's a component of it. So our least common multiple for our denominators would be a 5 and an x squared. So big parentheses around the whole problem. And then we're going to multiply every term here, and this is different from last week. Remember, we're multiplying it by 5x squared over 1. And I know this next step seems really obnoxious because you have to write a whole bunch out. It's really worth it, especially with you guys being new to this. So I'm going to spread out the problem, x minus 3 over 5x squared. Leave a little space in front. Again, leave a little space in front. You got 1 over 5x squared. Plus, and then leave another little space in front. We've got x squared minus 2x minus 8, which I know feels like you should factor it, but if you look at your steps on that little yellow reference card, it doesn't say to factor the numerators right now. It actually doesn't tell you to factor the numerators ever, unless you're simplifying. All right, so this next step, that LCM, right, is in front of it. So 5x squared over 1 gets multiplied in front of each of your terms here. So here comes these simplification bubbles, Each of these multiplication problems we're going to need to cancel and simplify. Ooh, that one's going to be weird. We'll talk about that. All right, and then this guy. I don't know why I can't draw bubbles anymore. All right, time to simplify, time to cancel. Apparently it's time to learn how to spell. All right, here goes. So first bubble here, the 5 and the x squared both on top and bottom, so they're going to cross off, which means you simply have the x minus 3. Denominator knocked out. Good job. If you notice that you're doing this work and your denominators aren't completely knocking out, that means you didn't come up with the least common multiple. Whatever you're trying to multiply by in green is too small. You got to go bigger. All right, this next one is where everyone messes up. So 5x squared and 5x squared do cancel. But they don't disappear. There's still a factor of 1 over 1, which we know is 1. So a lot of kids will write nothing down here, and what they really need to write down is a 1. Oh boy, here we go. The x squareds will cancel, but be careful. You're multiplying this 5 times the quantity x squared minus 2x minus 8. You gotta distribute that. So I don't like to jump ahead in my work, especially on these tricky questions, because I'm sure you've seen this. This is the kind of algebra where a teeny tiny mistake really messes with you. Okay, now it's time to distribute and simplify. And then this problem should be extra fun because I think we're going to get a quadratic. All right, so we got a 5x squared, a minus 10x, and then a minus 40. All right, so because this is a quadratic, meaning we have an x squared term that's not going to cancel out, that means you need to set it equal to 0 and then probably factor it is the way we're going to go. So this is no longer a linear equation. This is like quadratic rules from Algebra 2 first semester. So here goes. I'm going to bring everything to the right side. So I'm going to subtract the x. I'm also going to add the 3. But guys, don't forget there's also a random 1 over here, so keep that in mind when you're selecting or simplifying all your like terms. So 0 equals, let's see, I got a 5x squared. This is minus 11x. Oh boy, I can do this. So negative 36. Right? Negative 30, so yeah. I think so. we'll find out in a minute when I can't factor it. Okay, so again, factoring is generally the way to go when we're solving quadratics for Algebra 2 questions. If you couldn't factor it or you just were having a hard time, you could always use quadratic formula, but you'd have to have that memorized. Okay, beginning terms here. I need my beginning terms to multiply to a 5x squared, so they're going to have to be 5x and 1x. And then my favorite number, 36. Oh boy, guys, there's a lot of options for 36. You know, there's 6 and 6, there's 9 and 4, there's 12 and 3, there's 18 and 2, there's 36 and 1, but we know that one's going to be a bad choice, so I'm not going to bother with it. Usually I'd start with 6 and 6, but that's going to be 30, and that's not going to work out. So I'm going to scrap that one. I'm going to go with 9 and 4. I'm going to put the 4 here. I'm going to put the 9 here. And I know one has to be positive and one has to be negative to multiply to negative 36. And I'm going to make this guy negative. Let me show you why. Because now I have, whew, that's a negative 20x right there. And this is a plus 9x. And if you were to add those together, you get that negative 11x in the middle. All right. Unfortunately, thank you, algebra, we're not done. Because now I need to take those factors and actually solve them. So this factor right here, 5x plus 9 equals 0. I'm going to have to solve that in addition to solving this one. X minus 4 equals 0. This one takes a couple steps, but it's not awful. You're going to subtract 9 from both sides. And then divide by 5. So negative 9/5. And then over here, obviously that one's easy. Add the 4 over. And before I get too excited to walk away, I got to make sure I didn't use my excluded value. The one thing I can't have is x can't be 0. And I didn't get that. So both of these answers are good. And this is a case where you get a rational equation with 2 solutions. All right. So you have an assignment. Oh, I need to go back a slide. Sorry, I had to yell at my kid. Okay. So you have an assignment to start. You're just going to do a part of this, maybe. If you look through your assignment, you're going to notice the questions that have, there's some excluded value questions, and then there's some questions that have denominators that are monomials like we had today. Focus on those. We'll continue this lesson tomorrow.